Chapter 2, Section 2.4, Math 110. In the beginning of this section, we are introducing some of the graphs that are kind of very common. One is when you have an equation of a straight line, the highest power of x is 1, and graph is always a straight line, like in this case, y equal x. Or you might have equation that doesn't have any x in it, like y equal c or f of x equals c. So example, y equal 3. Y equal 3 is a straight line and is a horizontal line. Every point lie on this line has y value of 3. Or you might have x equal -2, x equal a number. That is the vertical line. So you either have a vertical line or a horizontal line. Another popular graph is a parabola, which is y equal x2. So when the degree of x goes beyond 1, like 2 or 3, then is a curve, it's not a straight line anymore. So this is one of the graphs that we use very often, and then we do the translation on this. Then it would be graph of y equal x3. This is the odd functions because the power of x is odd versus the other one, which is even functions. Even functions, power of x is 2. So in that case, if you take any value of x, for instance, x equal 3, and substitute, the value of y is 9, and for x equal -3 also, this you got the same value of y. That means this type of graph are symmetric with respect to y-axis. And power is even. But the odd functions, the power is 3, and they're symmetric with respect to the origin. And then this graph of y equal radical functions. What you have under the radical always has to be 0 or greater, because if you have a negative number under the radical, it's undefined. So graph of radical x, this is graph of radical x. And it's just on this piece because x is always positive. Therefore, y is positive. This is in case graph of y equal 1 over x. This graph exists for any value of x except 0. When you substitute x equals 0, then the y is undefined because 1 over 0 is undefined. So this function has discontinuity. It breaks at x equals 0. X equals 0, in fact, is the y-axis. So anytime you have a graph which is the fractions and denominator has an x in it, then whatever number make the denominator 0 are lines that break the graph. They call it asymptotes. All right, and then there is this graph that we discuss later on as how to apply it. In this case, they are saying which one of this is the correct answer. They call it the greatest integer function. As I said, we explain about this later on so you understand how to deal with this type of function. Now, in algebra, when we give you coordinates of 2 points, and ask you to find the equations, what you do is you find the slope from this formula. When you find the slope, then you take the slope and 1 point and use these equations to find your final equations here. Okay? When they say f of -5 is equal to -6, that means when x is -5, y is -6. Or when they say f of 2 is 5, means when x is 2, the value of y is 5. So basically, we are giving you coordinates of 2 points. And you have the solution of this already in your copy. This problem is very similar. X is 1, y is 3, x is 0, y equal to 9. Very similar to that one. You could find the slope, then write the general equations. Take x1, y1, take x1, y1 and the slope and find your equations. You could use these points in order to plot. And remember, equation of linear equations is the graph is a straight line. So you could use these 2 points to draw the line. This is another equation which is a straight line because the power of x is 1. So you could either plug some points or you could use your calculator. But the problem like that, since they give you all the pictures, if you actually find your x and y intercept, like here, if you put 0 for x in the equations, the equation was y equal 2.5x minus 4.96. If you put 0 here, then what's the value of y? Minus 4.96. Or if you put 0 for y, what's the value of x? You put 0 for y here, so that means 2.5x minus 4.96 is equal to 0, or 2.5x is 4.96, or x is almost 1.98, or basically is almost 2. The only graph that has these coordinates is this one, look. This intercept is 2, and wait a minute, I'm sorry, is the top one? Is this one. Minus 4.96 and x equal 2. It's the top one. Or you could use your graphing calculator and see which one is correct. We discussed about equation of y equal x to power of 3, which looks like that. So if you take that one and shift it down 2 units, this is what you have. Is this one. So originally it was y equal x cubed. Absolute value. How do you graph of absolute value of x? Graph of absolute value of x, this is absolute value of x. Because if x is 2, what's the value of y? 2. What if x is negative 2? Y still is 2. Okay? So it's like this. What you have in the problem is absolute value of x minus 6. That means just shift it down 6 units. And you could just, if you want to know which picture is correct, you could just substitute 0 for y and find the x. X give you 6 and minus 6. That's another way to do. Now, I put a page here that explains step functions or step and piecewise functions. In this function, when you substitute a value for x, the value of y, if this x is whole number, then the value of y is that whole number. If it's not a whole number, it's a decimal, then you move to the left to find the whole number. For instance, here, x is negative 1. It's a whole number, so y is negative 1. That's fine. But here, x is minus 0.5. If x is not a whole number, like this, then you get to move to the left to find the very first whole number, which is negative 1. That would be your y value. Okay? So look, x is 110. X is here, 110. It's not a whole number. I need a whole number. So from this point, you move to the left. The very first whole number is 0. So y is 0. X is 1.5. 1.5 is not a whole number. So you need to move to the left to find the very first whole number, which is 1. 1.9 is not a whole number. You move to the left to find the very first whole number, which is 1. That's how to find the y value. Domain is all real numbers and range is all set of all of. You could put any numbers here. And this problem is, this problem is very similar to that. So for each of this, you find it. Okay, so let's go to the bottom of the full board. In this one, 1.1. 1.5, 1.1 is not a whole number, so you move to the left, the very first one is 1. 1.9, 1.9 is not a whole. Move to the left to find the very first whole number is 1. 1.9, 1. Minus 4.5, minus 4.5 here is not a whole number. You move to the left to find the very first one, negative 5. 7.5, which is basically 3.5. 3.5 is not a whole number. You move to the left to find the very first one is 3. Okay? First, you take that 8 and substitute for the x. Inside this bracket, you have, and of course, they all have double, remember. You just have double for all this. Just a symbol. Okay? All right, so inside, you have a whole number. So if you have a whole number, you pick that for the y value. Minus 1.56, I'll put that one inside. You end up having a decimal number. You move to the left, the very first one is 3, see? You put here, 6.05, you move to the left, the very first one is 6. 15.5, you move to the left, the very first one is 50. That's how you find the y value for this type of step functions. Here they show you how to graph this one. You know, if you put x equals 0 here, it's a whole number, right? So what it comes out of this is 0, and minus 0 is 0. Or if you put or if you put 2 here, it's a whole number, right? So it would be negative 2. This 2 comes out and there is a negative. Now remember, between 0 and 1, there is all these decimal numbers. Like what if I put 0.2 here or 0.9 here? When you put 0.9 for the x, because it's not a whole number, in order to come out of this, you have to move to the left. So very first number is 0. So it's coming. So for all these numbers, 0, 0.1, 0.2, 0.3, all the way to 0.99, the y is always 0. That's why you get a straight line here. But it's not 2, it's not 1 yet. It gets close to 1, but it's not 1. That's why it's an empty circle. A minute you substitute 1, a minute you put 1 here, then the y is negative 1. So you jump to the negative 1 when you put 1. And then from 1, 1.1, 1.2, 1.3, all the way 1.9, they all, when you move to the left, is just 1, 1, 1, 1, 1. And then since there is a negative outside, it's a negative 1. That's why we have a step functions. Okay. This is a type of graph that there are more than one equations. If you are substituting a number, negative 2 and less, you have to use these equations. See, I show it to here. Like when x is negative 2, you put it here, negative 2 plus 6 is 4. When x is less than negative 2, when x is negative 3, you put it here, negative 3 plus 6 is 3, and so on. But if you want to substitute a number greater than minus 2, right, like minus 1, 0, stuff like that, then you have to use these equations. For numbers greater than negative 2, like here, if you want to put negative 2 to the right to pause any number between negative 2 and infinity, then you use these equations. So in that case, there are two pieces of graph, two separate graphs, and they're broken here. The reason we put filled, this circle is filled because it is equal to negative 2. But the other one, it doesn't start from negative 2. It's a little bit greater than that. That's why it's an empty circle. This is also 3 pieces. If you want to use x less than negative 2, then you have this. When x is between 0 and 2, then use this equation. When x is greater than 0, use that equation. That's how you pick this graph. So 3 separate functions. here, if you want to take a number for h, which is 30, use this equation. If the number is between 0 and 40, you always use this equation. So here it's 30. 30 is less than 40, right? So we use this equation. So 16 times 30 is that. When h is 55, if h is greater than 40, like here 55, then use these equations. All right, so that's how you do it.